السلام عليكم. اهلا بيكم حبايبي طلاب IGCSE OL كامبريدج. انا معاكم دكتور احمد عيد، وان شاء الله هنرجع نكمل السيشنز بتاعتنا، هنكمل الفيديوهات بتاعتنا، وهنتكلم ان شاء الله النهارده عن الكيميكال بوندنج زي ما وعدتكم. طبعا انا بعتذر عن غيابي في الفتره اللي فاتت، بس كنت تعبان شويه، وان شاء الله احنا هنكمل في مواعيدنا اللي احنا كنا متفقين عليها، وان شاء الله هيكون في فيديوهات مستمره. بالاضافه ان انا هنزلك على صفحه الفيسبوك، هنزلك تقريبا بشكل يومي اسئله related to chemistry related to IGCSE او Cambridge، وكمان هيكون في شرح لل AS Edexcel وال AS Cambridge وال OL Edexcel. لو انت حابب تشترك معايا في الكوندنسد كورس الريفيجن للاكزام، هنشرح فيه كل التوبكس بطريقه مكثفه، هنحل فيه معظم الباست بيبرز الريسنت. تقدر تتواصل معايا من خلال ال QR كود ده. Let's start talking about chemical bonding. If you check this picture, we have NH3 ammonia covalent compound. We have CH4 methane covalent compound also. We have sodium chloride, which is considered as ionic compound, and we'll talk about all of this, one of these during this session and the other during the next video. As we just mentioned, our topic today will be chemical bonding. Why are compounds formed? Atoms of all elements, except noble gases, tend to combine with each other to attain stable electronic structure of the nearest noble gas. So, why are compounds formed? All elements, but except noble gases. You know that noble gases are unreactive because they have full outer shell. So, all elements except noble gases tend to combine with each other, join to each other to attain stable electronic structure of the nearest noble gas. While the noble gases itself, like helium, neon, argon, unreactive, stable, because their atoms have full outer shell of electron. So this one is considered as a repeated question. They ask you about why noble gases inert, why noble gases not react. You have to say that because their atoms have full outer shell of electron. Do not say 8 because helium contain only 2. Let's compare between ionic and covalent compounds and ionic and covalent bond. Ionic bond formed between metal and non-metal, while covalent bond formed between two non-metals. So if you found metal with non-metal, so it's ionic. Two non-metals, so it's covalent. And you know from the periodic table, the elements in the right-hand side considered as non-metals, most of them, and the elements on the left-hand side considered as metals. In case of ionic bond, metal lose electrons and they change to positive ion. It's like sodium converted into sodium positive. That's for metal. Non-metal gain electron or electrons and they change to negative ion. It's like Cl gain one electron to give Cl negative. We'll check all of this and explain this in details later in this topic. While in case of covalent, keyword share, two non-metals share equal number of electrons. So you know now that ionic bond formed by electron transfer, while covalent bond formed by just sharing electron between two non-metals. Now, let's check differences between compounds and mixtures. Compound, like for example sodium chloride, like H2O, water itself, mixture like salt and water, for example. So compound is single substance. As I told you, water, H2O, compound. NaCl, compound. Mixture is a mixture of two or more substances. Salt in water means we dissolve NaCl in water. The composition is always the same. If you bring pure water, you will find that every part of it the same composition. While in case of just adding salt in water, you can find that part contain more salt than the other. so the composition can be varied. The formation of compound involve a chemical reaction. If you want to form sodium chloride, you have to react sodium with chlorine, while no chemical change takes place when made for mixture, just adding salt and water, and you can separate both of them physically. The properties are different from the elements present in the compound. This means what? Hydrogen, flammable. Oxygen, help in burning or combustion. When adding them together, they form water, distinguish fire. While, in case of mixture, the properties of substances making the mixture are still present. Properties of water and salt still the same. Can only be broken down by chemical reactions. If you want to separate oxygen from hydrogen, in case of water, you have to make chemical reaction. While this substance or the substances present in mixture can be separated by physical methods, and we will take the methods of separation in topic 12. One of them, if you want to separate salt from water, you can do evaporation for water if you don't need water and get just salt, or you can do crystallization to get also salt. If you want water, you can make simple distillation to get water. As you can see from this page or from this picture, you will find that mixture of iron and sulfur can be separated by magnet. Magnet will attract iron, while iron powder and sulfur react together to form black compound, which is called iron sulfide, which is not magnetic, cannot be separated by a magnet. Now, we will start talking about ionic bonding. Compounds formed when electrons are transferred, as I told you, transferred from metal to non-metal. Electron transfer, not sharing. We are talking now about ionic bonding. Electron transfer, not sharing. Ionic compounds are made up of ion, from its name, ions. Ionic compound, ions. Okay, let's start with metal. Metal, like sodium, lose electrons and change it into positive ion. Check this. Sodium containing 11 electrons. We can make electron distribution 2, 8, 1. So it contains 1 electron in the outermost shell. It's easier to lose 1 electron than gaining 7 electrons. Just lose 1. Metals prefer to lose. So sodium lose electron and change it into positive ion or cation. You just remove the outermost shell electron and now it contains 2 and 8. The outer shell now is full. Or you can say the outer shell is empty. It's okay. And just putting positive charge outside these square brackets. So metal like sodium lose electron or electrons. Some metals lose more than 1 electron. And they change it into positive ion or cation because the number of protons not changed. 11 protons. Number of protons will be greater than number of electrons. It lost just 1 electron. So it contains 11 protons and 10 electrons. You know that protons positive and the electrons negative. So it contains 1 positive more than negative charge اللي هي electrons. So we can say that sodium ion is positively charged. Positive 1 because it lost 1 electron. Let's talk about non-metal. Non-metal gain electrons and change it into negative ion or anion because number of electrons now greater than protons. Check chlorine. Chlorine containing 17 electrons. We can make electron distribution 2, 8, 7. 7 electrons in outermost shell, so it gain 1 electron to convert into chloride ion. Remember that it contains 1 electron more than protons. This means negatively charged, negative 1. Contain 17 protons. Number of protons not changed, so it contains 17 protons and 18 electrons. When we draw it, the outer shell contains 8 electrons and we have to add negative charge right here. Now, positive ion, sodium ion, attracts negative ion by strong electrostatic attraction, and this is the meaning of ionic bond. Ionic bond is electrostatic attraction between oppositely charged ions. Definition of ionic bond: electrostatic attraction forces between oppositely charged ions. Check this. We just take one electron from sodium atom and transfer to chlorine atom. This makes sodium positive, 11 protons and 10 electrons, so overall charge positive 1. And the electron, take care, it's different from the 7 electrons. When we draw dot and cross, we'll check this in this video. When we draw dot and cross, you can see that one electron is different from all other electrons of chlorine or chloride ion. So the outermost shell containing now 8 electrons, 1 electron is coming from sodium, 17 protons, 18 electrons, so overall charge will be negative 1. You have to write the charge over the square brackets right here. And now let's try to solve one practice question together. Before solving this question, you have to know that ion is an electrically charged particle formed from an atom by the loss or gain of one or more electron. When sodium lost one electron, it converted into positive ion. When chlorine gained one electron, it converted into chloride ion. So we can say that ion is formed. It's considered as an electrically charged particle formed from an atom by loss or gain of one or more electrons. Now let's solve our question. This practice question, was in October-November 2024, variant 23. It says that what happens when sodium atom combine with chlorine atom to form sodium chloride. First choice, sodium atom each gain one electron. We cancel gain. Type, check C or D. Sodium atom and chlorine share one electron, share 2 electrons. We talk about ionic bonding and we just mentioned it's electron transfer, not electron sharing. Electron sharing in case of covalent bond. وcovalent bond ما فيهاش sodium, no sodium in covalent bond. So we can exclude all of this. Sodium atom each lose 1 electron, yes, and chlorine atom each gain 1 electron. This one is considered as the correct answer. If you want to join the condensed course or even contact me for any question, you can use this QR. Courses available for OL Cambridge and Elixir, AS Cambridge and Elixir, A2 Cambridge and Elixir. Let's check our next part. Now, let's talk about dot and cross diagram. A dot and cross diagram can model the transfer of electrons from metal atom to non-metal atoms. Electrons come from one atom, shown as dots, and the electrons from the other atom shown as crosses. Any one. You can use dots for one and crosses for the other one, and vice versa. For example, when sodium reacts with chlorine, electrons transfer from sodium atom to chlorine atom, so the outer electron from sodium atom transfers to the outer shell of chlorine atom. Now we are talking about dot and cross diagram for sodium chloride, NaCl. As you can see, sodium containing 1 electron in the outermost shell. This electron transferred to chlorine. We draw dots for sodium, so crosses for chlorine. Just getting 1 electron from sodium in the outermost shell of chlorine to give sodium ion positive. You can draw all of this, and sometimes in exam, he just mentioned to draw the outermost shell. So you can draw just sodium, Ne, without any shells, because the outermost shell is empty now. And chloride ion gain 1 electron. As you can see, 1 electron is different from all other electrons. This electron is coming from sodium. So we have sodium ion, which is positive, and chloride ion, which is negative. Let's check dot and cross diagram for magnesium oxide. In case of magnesium oxide, MgO, magnesium containing 2 electrons in the outermost shell and oxygen containing 6 electrons in the outermost shell, so magnesium need to lose 2 electrons and oxygen need to gain 2 electrons. So 2 electrons transfer from magnesium atom to oxygen atom to give magnesium positive 2 ion and oxide negative 2 ion. As you can see, 2 dots coming from magnesium and all the other electrons are crosses, as you can see. For magnesium chloride, magnesium need to lose 2 electrons. Magnesium contains 2 electrons in the outermost shell, 12 electron configuration 282. This means 2 electrons in the outermost shell, but each chlorine atom require or need 1 electron. So we just put 1 electron right here and 1 electron right here. This means magnesium will combine with 2 chloride ions. This gives magnesium positive 2 and 2 chloride ions, each one with negative 1. This means the ions from a lattice with 2 chloride ions for each magnesium ion, so that the compound magnesium chloride has now no overall charge. Let's start talking about the giant electronic structure or the giant ionic lattice. This part for grade 10, not 9. It's considered as regular arrangement of alternating positive and negative ion in ionic clusters. The ions are held together by strong electrostatic forces of attraction between oppositely charged ions. And this explains the high melting point of ionic compound. This tells us why ionic compound contain, or why ionic compounds have high melting and high boiling point. If you check this, you'll find that sodium chloride in a lattice alternating positive and negative ions held together by strong ionic bond. We can draw it for simplification like this. You can see that each sodium ion surrounded by 6 chloride ion and each chloride ion surrounded by 6 sodium ions. This is considered as the structure of sodium chloride. Still talking about giant ionic structure or giant ionic lattice. Ionic crystals are hard, but brittle, much brittle than other types of crystal lattice. Let's check this. If force applied right here, as you can see, we just slide these layers down. This means negative is near to negative and positive is near to positive. This makes repulsion and make the crystal to fracture. يبقى in ionic crystals, when one layer is forced to slide against another, repulsions cause the crystals to fracture. This means it's brittle. What are the properties of ionic compounds? They are solids. They have high melting point and boiling point. The melting point of sodium chloride, for example, is 800 degrees Celsius. This is due to electrostatic attraction force, or we can say strong electrostatic attraction force between positive and negative ion. So if they ask you why solid ionic compound, or even why ionic compounds have high melting and boiling point, you can say due to strong electrostatic forces of attraction between positive and negative ions. Solid ionic compounds do not conduct electricity because ions cannot move. In case of solid, ions cannot move. But they conduct electricity when melted or dissolved in water. When melted or dissolved in water, due to ions are free to move and carry electric current. Again, solid ionic compound, solid, do not conduct electricity. Ions cannot move. In case of solid, explain why. Why solid ionic compound cannot conduct electricity? Because ions cannot move in case of solid. Molten or dissolved in water aqueous solution conduct electricity because ions now are free to move and carry electric current. They are soluble in water, but insoluble or not in organic solvents such as ethanol. So they can dissolve in water, but not dissolve in organic solvent. As you can see, sodium chloride lattice like this, water get ions out from this crystal lattice. This means oxygen surround oxygen and water, which is in red, surround sodium or positive ion, which is in yellow, and hydrogen part of water surround the chloride ion, which is in whatever this color. Let's solve one practice question. Draw dot and cross diagram for ionic bonding in the following compounds and give their formula. For lithium fluoride, lithium, it's like this, positive ion, and fluoride like this, negative ion with one electron transferred from lithium. Sodium oxide, as you can see, 2 sodium ions, and oxygen gain 2 electrons, one from each sodium, to give 2 sodium ions, Na2, and 1 oxide with -2. Magnesium positive 2, this means 1 electron transferred to one chloride and the other electron to the other chloride, this means MgCl2. Let's solve some practice question. First one, it's from October-November 2024, variant 21. The diagram shows part of ionic lattice structure. Which compound does the diagram represent? If we check positive ion, check the positive ions, we have 1, 2, 3, 4, 5, and 6. This means 6 positive ions. 1, 2, 3, 4, 5, 6, and 6 negative ions. This means what? This means the ratio is 1 to 1. So we have to check ionic compound with the ratio 1 to 1. Carbon monoxide is considered as covalent compound, so we cancel this one. Potassium bromide, K, Br, 1 to 1. This one, what we want. Sodium oxide, Na2O. Sodium positive 1, oxide -2. This means Na2O. This one is not our choice. We know that the correct answer is A. Magnesium chloride, MgCl2. 1 magnesium with positive 2 and 2 Cl, each one with -1. So the correct answer, potassium bromide, because the ratio in case of potassium bromide is considered as 1 to 1. If you want to join condensed course, you can contact me via this QR. Let's solve another practice question from October-November 2024, variant 22. Which pair of elements react to form a compound with a strong attraction force or attraction between oppositely charged ions? He mentions that ionic compound. He asking about ionic compound. Carbon only share electron. So carbon is considered as non-matter. Bromine and nitrogen also, both of them non-matters. So we are talking about sharing electron or just share. This means it's not A or B. Sodium and oxygen. Sodium positive, oxygen negative. So this one is considered as correct one. Sodium and potassium. Sodium form positive ion, potassium also form positive ion. They cannot form bond with each other. This means the correct answer is sodium and oxygen. And as I told you, you can contact me anytime with your questions through this QR, and you can ask me for the link for a Facebook page and Telegram group. Let's solve the last question from October-November 2024, variant 23. The table shows some properties of 4 substances. Which substances are ionic? He asking about ionic. So check melting point. Melting point of ionic compound is high, not low, so we can cancel 3. If you cancel 3, you cancel this one and this one. Let's check electrical conductivity when solid. Electrical conductivity when solid for ionic compound is considered as poor electrical conductivity. So this one says good. We cancel 4. So the correct answer will be 2 only. High. Electrical conductivity when molten, it's not poor. It's good electrical conductivity when molten. So the correct answer, as I told you, 2 only. Now we finished our lesson, our video for ionic bond. Next video will discuss together covalent bond and solve questions together. You will find that several questions, or even every day, You will find questions on my Facebook page هي كيمياء, and also you can contact me for condensed course whatever OL, AS or A2 through this QR. See you later and wait for the next video. Salam alaikum.